All right, so here we're back again. So number 24, and we're going to go from here to Desmos and back again so you can see in terms of a limit. So we're trying to find the limit as x approaches 3 of this. Step 1 to evaluate a limit is to do a substitution and see if it actually works. So if you substitute in 3, what answer do you get? And you get 0 over 0. You get this indeterminate answer. So we're going to go to Desmos to see what the answer is. Now again, I'm not looking for what the answer is at 3. I'm looking for what the answer is as it's approaching 3. So I'm going to graph this and do a little table, perhaps. So I'm going to go y1 equals, I'm going to type in 9 subtract x squared, and then it's x subtract 3. So if I want to know at 3, so first of all, at 3, there's not going to be an answer. But I can get a sense of it here off the graph. So here at 3, as I'm approaching 3, I can see that at 3, it's undefined. In fact, you can see a cute little hole on Desmos if you're accurate enough. And then before and after, what the answer is. So if I do a table here, I'm going to remind you of that. You can have, this should say x, and this should say y1. Give it a moment. And then as you plug in values like 1, 2, 3, you can see 3 is undefined, and then 4, 5, 6. So what answers are we getting close around? So even by just doing this, what answer do you think 3 produces, or that it's getting closer to? So if you see the pattern here, you can see it kind of looks like -6. But let's just do a little bit here in terms of our table. And we're going to pick numbers really, really close to 3. So we're going to pick a number like 2.9, 2.999. We're going to pick it on the other side, which is like 3.01, and then 3.001. And is this affirming what I think? Is the y-coordinate getting closer to a number on both sides? And it is. So if you round that, what's the number it's getting closer to? And you can see the answer here is -6 for 24. All right, 25. Next, I want to plug in -4 and see what the answer is. So if I look at that, let's go back to our graph. And let's type this in. So I'm going to get rid of that. So we're going to go y1 equals, and I'm going to type in absolute value, x plus 4. And then in the denominator, just x plus 4. Now, I want to look off the graph and see what's happening. So do you see we have 2 horizontal lines, but at an x value, it jumps. And so we want to know what the value is as it's approaching -4. But do you see at -4, there's a jump. So even off the graph without a table, I can see from the left, the y value is -1. And then from the right, it jumps up to +1. So from -1 to +1. They don't agree. They don't approach the same answer. The left approaches -1. The right is approaching the answer +1. There's a jump. And if you have a jump, that means the limit does not exist at that number. So if there's a jump at -4, then it doesn't exist. If you're trying to find the limit at a different number on here, it would exist, only where the jump is located. So I want to know when x is approaching -4. That is where the jump is. Therefore, it does not exist, like the movie Mean Girls. 26. Again, we're going to use a graph for this one. Cosine 1 over x as it approaches 0. Or we might use a table. So I'm going to make sure that we're in radians when we do this, and it is. So make sure yours is in radians. So I'm going to go y1 equals cosine. If you go to functions and then trig, you can see cosine. And I'm going to type in 1 over x. So what is happening, and I'm going to zoom in here. No pun for our meetings. What is happening around 0? So as I zoom in, can you see that this graph is going up and down, up and down, up and down, up and down? So as I try to get closer and closer to 0 to understand the values of it, the graph is going up and down, up and down, up and down. So at 0, it does not exist because it's oscillating right at 0. So the left and right, it doesn't agree with the answer is. There's no y value it's getting closer to. So for that reason, and if you go back, that's one of the reasons is oscillating. That means it goes up and down, right over the number. So right at when x is 0, the oscillation, the up and down means the limit does not exist. 27. Let's type that in. So let's get rid of that one. So y1 equals, and you could do it on your phone and then have it maybe on your Chromebook and be able to quickly go back and forth between the two. So we have 1/2. I have sine. If you just type in sine, it works too. Sine x subtract pi over 2. All right, so there you go in terms of typing it. Now, what we want to do is, I'm going to press the home screen here. Just give me 1 second.
Go back to mommy, please. Yeah, go back to mommy, please. I'm in the middle of the video.
Why is she here? I'm so sorry.
All right, I'm back. Sorry. My little daughter was at the door as I was trying to do this. It happens. I'm sure it probably even happened here. So I'm back. Here we go. Not going to redo this video. So when I look and I just press the home button to take me back, as x approaches 0, what answer is the y coordinate as the limit is x approaches 0 of this? So I want you to know from the right and from the left, they agree that as x approaches 0 of this, the y value is negative pi over 4. And you could have actually done a direct substitution here. For here, I just looked off the graph, clicked it, and go, okay, when x is 0, we actually have an answer. It's clearly this. There's no jump, no oscillation, none of that. No asymptote. Just the answer. So it's negative pi over 4. (28) What's the limit as x approaches pi over 3 of negative cosine squared x? So let's go back to the graph. So negative cosine, we're going to square it, x. So negative cosine squared x, I'm looking at 0 again. So what's the y value? The y coordinate. What is it approaching? Oh no, sorry, it's at pi over 3. So this is what I'm going to do for pi over 3. I'm going to not use, because I see there's no jumps or anything, I'm just going to evaluate it at it. So I'm going to change it to f at x equals, and then just type in 0. No, pi over 3, sorry. I'm going to type in pi over 3. Just using our computer rather than anything else. So, what's the value at pi over 3? Is it undefined at all? No. It's negative 0.25 at pi over 3. For 2 sine pi over x. Let's do that one right now. So 2 sine, and then inside pi over x. And that's as x is approaching 0. So what's happening around the origin? Is there an oscillation around 0? That oscillation means the limit does not exist. All right, on to number 30. Tangent at pi over 2. Type that in, tangent at pi over 2. Where is it? Sorry, tangent, just tangent x as it's approaching pi over 2. So just x. And then what happens at pi over 2? So let's look. I see a bunch of asymptotes there. So I'm going to type in pi over 2 here. And just know that at pi over 2, tangent is undefined. And it creates an asymptote. So because there's an asymptote there, and in one end it goes up, and the other end it goes down, we say that the limit here does not exist. And if I do the same thing for cosecant, so if I type in CSC, or you can go and do it a different way, that's the quickest way. And then again, if I type in the value as x approaches pi, again, I want you to notice the value is undefined. That means that happens at an asymptote. So at pi, there's an asymptote. On one side, it goes up forever. On the other side, it goes down forever. Therefore, at the asymptote, it does not exist. So, just to recap what the answers are from 26 to 31. And why does it not exist? It oscillates, asymptote and an asymptote at those x values that it's approaching. And then for these, you can actually find the y coordinate by substituting in the x coordinate, and you have your answer. All right, in some cases, the left and right side are both increasing without bound, or both decreasing without bound. And so look at the example to the right. Though the limit technically does not exist, we can describe the limit as follows. So I want you to look at this situation. These are one of the arguments in calculus that has not been resolved. So there are two answers that are possible here. When you are looking at a limit and it says at 0, does the right side and left side, are they going in the same direction? Yes. And where are they going? Both of them. They both are going to infinity. They agree. So when x is 0, what's happening on the right and left? The function's going to infinity. Or another mathematician's going to say this, that can you ever approach infinity? The concept of a limit is, what's the y value that you are approaching? So can you approach infinity? And so conceptually you can't. And so both are accepted as correct answers. And on an AP exam, both are accepted as correct answers. So if a limit and the answer is infinity because they both go there, then that's a good answer. Or you can say it doesn't exist because it's impossible to approach infinity. Crazy, right? Now, if one end went up and the other end went down, the only answer possible was does not exist. But if they both go in the same direction, then yes, you could write it that way. So let's look here. Negative 2x, negative 4. Let's look off the graph. Negative 2x. So if I type that in, what's happening around 0? And I want you to notice that both the right and the left are both going down. So one answer you could say around 0 is that the values on both the right and left are going to negative infinity, or you can write down does not exist because it's impossible to approach negative infinity. So there are two correct answers there. And yes, both will be accepted. So, but notice that both ends are going in the same direction around the number I'm looking for. So when I look at 0, what's happening to the graph? Both are going down. They're both going to negative infinity. So that's a good answer. Or conceptually, could you ever approach negative infinity? Nope. So therefore the limit does not exist. Both are correct answers. And one day maybe it'll be solved where one answer only will be accepted. But right now, both are true. All right, what's the limit as x approaches 0 of this function? 1 over 3x squared. So again, what's happening at 0? So both around 0 are going to infinity. So you could say this answer is infinity or does not exist. All right. That is your lesson for today, your first lesson on what a limit is. So if I'm going to remind you again what a limit is as x is approaching a number, what's the y coordinate? And is there a jump, an asymptote? Is it going to infinity? Then sometimes the limit does not exist. But the important part is there could be a hole exactly where you're looking at, and that does not preclude the answer that the limit can still exist as long as the right and the left are agreeing what the y value is as you are approaching it. So the difference is, do you understand the word approaching compared to the word equals? So approaching allows us the concept of a limit. When we get there, we don't have an answer. But we can make the number so small that we can know the answer as it's approaching, and that's what we're looking for. All right, Mr. G Math over and out. I am proud of you that you finished this lesson, and until next time.